Hi, everybody. This is Mr. Farley, and welcome to podcast 9.3. Where we're going to talk about concentration in pictures, molarity calculations, and molarity ice. Now, my problem is I'm looking for my calculator high and low right now, and I can't find it. So, hopefully, as you hear the doors stomping around here, I can find a calculator that'll work. Because you need your calculator as well. So, let's hop right into that. Mr. Farley, as he's walking, can't sign his name quite the same. So concentration is measured in molarity. So molarity is a ratio of moles over liters. So molarity symbol is capital M. So that means that it is capital M equals moles over liters. Okay. So concentration is a ratio of moles over liters. So you see how here this one has 1, 2, 3, 4, well, 1, 2, 3, 4, 5, 6, 7, 7 parts in the same volume, right? The water's the same level as 1, 2, 3, 4, 5. I'm not going to count them all, as lots of parts. Okay. This is called concentrated. This is called dilute. Dilute means not as much stuff in it. Does that make sense? Now, most of the particles in here are water. Look, there's Mickey Mouse. That's me. And there's just a few things in there. This one would be more concentrated because there's more things that are not water. So what we focus on is the stuff that is not water. Mm-hmm. So, for example, if you get a Gatorade, the flavoring is the most important part, right? Not the water. I mean, I know it needs the water, but we focus on that. But so we talked about the formula for molarity is moles over liters. But we rarely give you moles, you get grams. And we rarely give you liters, you get milliliters. Now, going from grams to moles is something we've done forever, it seems like. So what happens is you start out with grams. I'm sorry, you start out with mole. Oh, what did I do here? Oh no, I wrote the wrong thing. So what happens is we give you grams. So if I give you grams, if I say something is 10 grams of, say, CO2, then what you have to do is convert it into moles, and you do 1 mole of CO2 over, go to the periodic table, which is 44.01 grams of CO2. Sorry. And then you do that math. I have my calculator, so I can tell you what that is. 10 divided by 44.01 is 0.227. And then you'd put that number of moles up there. To change from milliliters to liters, move the decimal 3 places to the left. Here's 375, my decimal place would be here. 1, 2, 3. Hey, that's the answer right there. By 50, my decimal place is right here. 1, 2, empty space, empty space. Yeah. 45.3 gram sample of potassium nitrate, that's KNO3 to you and me, Ross, is dissolved in enough water to make 225 milliliters of solution. Determine the molar concentration of potassium nitrate. That would mean determine the molarity. Okay. So my dream is to do molarity equals moles over liters, but sadly I don't have moles. I have grams. So 45.3 grams of KNO3, and I have to convert that into moles. So I need to go to the periodic table. So 1 mole KNO3, and I go to the periodic table. KNO3. Potassium is 39.10, nitrogen's 14.01, and 3 oxygens are 48. So I add all those up and I get 101.101, and then 45.3 divided by that answer is 0.44. 0.448 moles. Now, again, I'm trying to do molarity. Now, if I have 225 milliliters of solution, I just swing my decimal round and round, get to 3 spots, and write it down. So now my molarity is going to be 0.448 moles over 0.225 liters. And I put that in my calculator. So the previous answer divided by 0.225, And my calculator tells me it, well, I'll do this one, is 1.99, and the unit is molar, like a tooth. There you go. Okay, so there it is. You know, I don't know why it's missing for some of it, but there you go. Get that number. Woohoo! Next. Ionic solutions split into ions. So what happens is these things dissolve. So AlCl3, what happens is it starts out as a solid, and then it splits apart. I'm Al plus 3, surrounded by water, water, plus Cl negative, surrounded by water. But if you notice, I have 3 chlorines over here, so I have 3 of them over here. Okay, and notice they have charges. Okay, so what this means is I'll get 3 aluminums. I'm sorry, you'll get 1 aluminum, coefficient of 1, and 3 chlorines, coefficients of 3 for this. So what that'll mean is I will have 0.25 molar Al plus 3, and I'll have 0.25 times 3, which would be 0.75 molar Cl negative. 3 because my coefficient is 3, or there's 3 of them in there. Okay. If I were to draw a picture of this in a beaker, okay, all I'm going to draw is the ions. For every 1 Al plus 3, I'd have to draw 3 Cl negatives. Okay. Now, if I have Na3PO4, we spent all that time learning those ions. We need to see that as a unit. Okay. And do you see how I have 3 NAs? 3 NAs. So I'm going to have 0.103 times 3 is going to be the molarity of Na, which is going to be 0.309 molar of that ion. And then I have 0.103 times 1 is going to be phosphate, and that's going to be 0.103 molar phosphate. So notice how those the concentration of those ions would change. So notice up here, remember I had 3 Cl's for every 1 Al. Here I'm going to have 3 NAs for every 1 phosphate. So if I were to draw a picture of it, it'll be really simple for this one. I don't know where that went, but I'm going to have Na positive, PO4 negative 3. Notice how that stays together. Na positive, and they're drawn separately. I did not show the water in there, but believe you me, that water's in there. Next one, got a little stoich. How many moles of lead 2 hydroxide, this guy, can be formed? 1.225 liters of 0.135 molar lead nitrate solution reaction with excess sodium hydroxide. So I want to know how much of this I have, and it tells me I'm starting with this. Do you see how I'm changing my substances? When I change my substances, that means I need to do an ice diagram. And ice diagrams have to be done in moles. So what I'm going to do first is I'm going to figure out how many moles there are in this. Okay. Now, if you remember, molarity was moles over liters. And we use moles so often. Moles equals M times liters. Okay. So if I want moles of lead nitrate here, I'm going to have moles equals the molarity, 0.135, times the volume, 0.0225. .135 times 0.0225 is going to be 0.00304. 0.00304 moles of, and I'm going to label it again, PbNO3. Second twice. Okay. So I'm doing my ice diagram. I know my moles here are 0.00304. 0.00304. And the question says, how many moles of this guy? Okay, so this starts out as a 0. Get back here. Minus 0.00304. This will be plus, notice my coefficients are the same. It's going to be plus 1 over 1, 0.00304. And I know that's going to be 0.00304 moles of PbOH taken dosey. Woohoo! That's it. So, know your, oops, that's not what I want to do. Know your gas formulas. Know your molarity formulas. And then, I can't believe I did that. Grams to moles. I know how to do that. Milliliters to liters. I know how to do that. And I know how to say goodbye. And that is toodles.